Hello, good afternoon. We're team number 8, and we're going to talk about the methodology for our project water restoration. We are Jorge Alberto Chavez Chi, Jose Morales Luna, and Luis Ernesto Iñiguez Olagues. First of all, we want to give you a brief explanation of our theoretical framework that we did in the last phase. First, our topic, as we said, water restoration, the research question, which elements are the indicated ones to convert the 3 types of water into drinkable water and how much of them is needed. Our hypothesis, if more smaller pieces of activated carbon are put into the filter, more toxins, chemical impurities, and other contaminants will be removed and the water will have more chances of being drinkable. So for our expected outcomes, we are directly connected to our general objective, that it is basically to create a useful, simple, and accessible water filter that supports the addition of wastewater, very bad quality water, and water from the tap, 3 types of water, and convert them into clean, drinkable water. The filter will be fabricated from recycled and organic materials, meaning it won't have a major ecological impact at the beginning, and it will be more beneficial in the medium to long term. We want to make this plan an scalable project that will level up as a possible manufacturing product. The reason for that is by making it cheaper and more accessible to more people and in many places of the country, if possible, we are going to start a tendency of sustainability inside homes. This means that we're going to be introducing people from medium to and low classes to know more about sustainability and water restoration by having one economic and homemade filter inside their homes. Then in our variables, the independent variable, that is the one that is going to be changing in size and in volume, is activated carbon. Then the dependent variables are pH water, water transparency, color, odor, turbidity, total amount of suspended matter, and conductivity. All of these are from water. All these measures are from water. And we have control variables, the ones that are not going to change, that are basically the materials for our filter, excepting the activated carbon.
Well, as Jorge already said, we are going to use different materials in order to make the 3 different filters. First, we have the activated carbon that this amount is going to change depending on the filter. We find it like in 136 pesos. Then we're going to use sand, that is 56 pesos more or less. The cotton, that is around 40 pesos. Rocks that we are not going to buy anything because we can find them in places that are near our houses. The gravel, that is 51 pesos. pH bars, 64 pesos. And then we're going to use 2 plastic bottles. The first one is going to be to put in the different materials in order to make the filter. And the second plastic bottle is going to be used to store the water that already passed through the filtration process. And finally, we're going to use a conductimeter that we already have.
Well, the procedure of this experiment is very simple. Our first step is that we will clean and sanitize, if it is possible, all the materials that will be used in our experiment. The second step is to cut the empty 5-liter water bottle from the bottom, turn it around with the cap facing downwards and hold it by a stand. The empty soda bottle cut by half. Inside, collocate the activated carbon, cotton, sand, rocks, and gravel, and putting them in order inside the bottle. Our third step is to pour slowly 1 liter of water in one side of the bottle. Wait until the liquid trespasses all the levels of filtration. Recompile the resulting water from the soda bottle. Our fourth step is to put the filtered water in a container that has measures in the metric system and check how much water is filtered. And our last step is to do a water quality test.
So this water quality test basically will give us the results of our experiment. With this, we're going to be proving if our water that comes out from the filter, the 3 types of water can be drinkable or not. And with this, we're going to base our analysis and our conclusions. First of all is the pH test. pH is the value that determines whether a substance is acidic, neutral, or basic, calculated by the number of hydrogen ions present. It is measured on a scale from 0 to 14, in which in the middle, example 7, is the substance neutrality. pH values below 7 indicate that a substance is acidic, and pH values above 7 indicate that it is basic. We are pretending to have an alkaline water that basically stands among 7.14 value in the pH scale. And with these pH results, we're going to be measuring them with the pH conductimeter and the the conductimeter. Then conductivity, again, we're going to be measuring it with the conductimeter. And conductivity is important because it means the conduction of energy by ions. Measuring the conductivity of water can provide a clear view of the ion concentration in water, as water is natural resistant to conduction of energy. Then lastly, we're going to be checking the quality observations of water. This means turbidity, clarity, taste, color, and odor of the water that are the dependent variables that we put in the project. Basically, matter suspended in the water absorbs light, making the water appear cloudy. This is called turbidity. Turbidity can be measured with several techniques. This shows the resistance of the transmission of light in water. Then the sense of taste can detect concentrations of few tens to several hundred ppm, parts per million. And taste can indicate that contaminants are present, but cannot identify specific contaminants. Then the color may suggest that organic impurities are present. In some of the cases, the color of the water can even be caused by metal ions. Color is measured by comparing different samples visually or with a spectrometer. This is a device that measures the transmission of light in a substance to calculate concentrations of certain pollutants. When the water has an unusual color, this is generally not a health concern. Lastly, the other characteristic is odor detection, which can be helpful because sniffing can generally detect even low levels of contaminants. However, in most countries, the detection of odorless contaminants is limited to strict regulations, as it can be a health hazard when some hazardous contaminants are present in a sample. So the repetitions and the sample. For this, we're going to be using a sample of three different types of filters, as we said. These three samples, we're going to be making three different repetitions of each filter. And each filter, we have three different types of water. So basically, we're going to be making 18 repetitions of the water filtration overall.
Finally, some additional aspects we have to consider. First one is the possible source of error. Some mistakes that we could make are because we don't put, or we are not going to put the correct amount of some material, or water is not going to completely be filtered, so leaving us with less than the liter that we put at the beginning. And well, since we have some limitations because the actual situation we're living, we cannot enter to the campus, or we don't have access to more complex materials to make a more complex filter or a more efficient filter. So we have to adapt to what we can reach in our houses or what we can have access to.
Well, also, as my partner said, the safety measures and regulations, for example, everything we're going to buy, it is going to be sanitized due to COVID-19. And also, we are going to measure water's pH to be sure that it is drinkable. And also attributing and referencing the work of others, obviously, our experiment needed previous investigation that is already referenced in the last document. So we are a team that recognizes the work of other people. Thank you very much for paying attention.